This is a great question for practicing L'Hopital's rule. We're asked to find the limit as x approaches 0 of arctan AX over tan BX. We can do this in two ways. Of course, the main way we're going to do it is with L'Hopital, but after that we will do it in a second way to confirm our answer. Now clearly if we put x equals 0 into this, well, arctan of 0 is 0 and tan of 0 is 0. So we have an indeterminate form 0 over 0, which is eligible for L'Hopital because it's 0 over 0, and therefore we can find the limit of the derivatives of the two. Okay, so let's have a look. First of all, what we need to do is we need to differentiate arctan of AX. Now most people remember how to differentiate arctan as differentiating arctan x over a, which they remember as being a over a squared add x squared. Well, we could use this. All we would have to do is put 1 over a instead. So the differential with respect to x of arctan x over 1 over a, i.e. ax, is equal to 1 over a squared, 1 over a squared, add x squared, multiplying through by a squared. That would give us a over ax squared add 1. That is actually the differential that we seek. But let's imagine that we couldn't remember what it was, and let's do it by first principles, if you like. We'll do it by implicit differentiation. So let's let arctan AX equals y, which means that AX by definition is equal to tan y. So differentiate both sides of this. We have that a is equal to sec squared y dy dx, because we're doing implicit differentiation. Now remembering that sine squared theta add cos squared theta is 1, and dividing through by cos squared, we get that tan squared theta add 1 is equal to sec squared theta. We can use that here. So we have that dy dx is equal to a over sec squared y, which by this here is equal to a over tan squared, and we know tan squared is ax, so that'd be a over ax squared add 1, which is the same as that. Either way, we found our differential of arctan AX, and of course the differential of tan BX, the differential of dx of tan BX is simply equal to sec squared BX times by the differential inside the bracket times by B. So therefore our limit simplifies to, or maybe not simplifies, but our limit becomes, by L'Hopital, our limit becomes the limit of a over ax squared add 1, which is the differential of arctan AX, over b sec squared bx, which is the differential of tan bx. Now as x approaches 0, cos of x, as x approaches 0, cos of x approaches 1, and therefore 1 over cos of x approaches 1, which is sec of x, and so therefore as x approaches 0, sec of x approaches 1, and so therefore our limit becomes the limit as x approaches 0. That becomes a over 1 over b, and sec squared of 0 is 1, so it becomes a over 1 over b, which becomes a over b, and therefore our answer is a over b, which is the answer to the original question here, a over b, by using L'Hopital. Okay, now in actual fact we can confirm this by another method. Let's use Maclaurin series. So arctan of x is equal to, the Maclaurin expansion is x minus x cubed over 3, my apologies, add x to the 5 over 5, add order of 7, and tan of x is equal to x add x cubed over 3, add 2x to the 5 over 15, add So therefore we have that arctan of ax over tan of bx is equal to, we have to just put ax in here, that will be ax minus ax cubed over 3, add ax to the 5 over 5, add over bx, add bx cubed over 3, add 2bx to the 5 over 15, add So the limit as x approaches 0, well, of course, clearly the order of x cubed and x to the 5 approaches 0, which just leaves us with the limit as x approaches 0 is ax over bx, and clearly the x's cancel, which is equal to A over B. So basically, it's one worth remembering, actually, because this is quite a common exam question. The limit as x approaches 0 of arctan AX over tan BX is equal to A over B. Okay, well, I hope you found this useful. If you have, please like this video and subscribe to the Gresty Academy YouTube channel. Thank you.